What he was able to show was that when you're trying to solve a problem and you're going to handle a number of ideas to do it at the same time, and as long as it will fit into the working memory, you've got a good chance of getting the answer. As soon as it exceeds the working memory capacity, you have virtually no chance of getting the answer. 2 papers published, the names are Johnston and Albana, you can see the titles. And when these papers were published in international journals, there was an immediate reaction from many people who were doing research who said, we don't believe it. This is too simple, too neat. And the experiment was repeated in many countries by many people with different ages, different science subjects, and it always gave the same results. So we're now fairly confident. Working memory then has a limited capacity. If whatever you're trying to do, it will fit into that capacity, you have a good chance of being successful. If there's too much to fit into the capacity, your chances of success are very low. Can we change our teaching? And by teaching, I don't just mean what we do in front of a class, but I also include textbooks, worksheets, assessment, and all the things that we use in teaching, computer programs, a lot. Can we change the way our subjects are presented so that overload of the working memory is less likely? In some ways, if you are aware of the problem of working memory, that's half the battle. Because instinctively, you will start to watch your school students in front of you. Then we rethink carefully how we present the topic in such a way that we're going to reduce that potential overload. First time it was done in Greece with middle school chemistry. And topics like the mole and the mole in solution were tackled because that happened to be in the curriculum in that country at that age. Notoriously difficult topics. And the lady who did this recast all the written materials in such a way that ideas were introduced step by step. There were little dialogue boxes. Pictures and designs were put in to help explain things. Things were repeated. Things were linked backwards to previous ideas continuously, to try in any way she could think of to reduce the possibility of working memory overload. Then she measured how well they'd understood the chemistry and compared them to students who were taught normally. The results were quite dramatic. Massive improvement in performance in the examinations. So we're now fairly confident that we can change the teaching by taking into account working memory so that the learners can understand better, they're more satisfied in their learning, and the results are they get better exam performance, which in some ways is incidental but rather important if we're going to survive as teachers. You can change your teaching, your worksheets, anything you give and deliver, just by taking into account this problem of the limitations of working memory, and you can change things so that the student learning can be considerably improved. It explains the difficulties, and it gives us a key to help make our science subjects and mathematics more accessible and more exciting. One of the in phrases in education today is problem solving. Every curriculum and syllabus under the sun always says we've got to have problem solving. Interesting, most people don't really define it properly, and it varies between subjects because we now know it's not a generic skill. However, from the point of view of working memory, all the problems that you've ever solved in your life have been done in your working memory. It's the only place that you've got to solve problems. And therefore, if we want to understand more about problem solving, we've got to think more about the function and the nature of how working memory actually operates. Most of you listening to this will have had to learn to drive a car at some time in your life. Now just think back to when you started. You can probably remember the day when you said, I'll never manage this. And you need the help of the instructor who is guiding you and directing you to focus on certain things. But once you've got, say, clutch control mastered, so that your accelerator foot, your clutch foot, and your left hand on the gear stick are now totally working together without having to think about it. It's what we call the process being automated. It doesn't take up any space in the working memory. You're doing it automatically. Then you've got bits left over of your working memory space to think about indicators, mirrors, steering wheel, and all the other myriad of things. As automation takes place, pressure comes off the working memory, and enough space is left to cope with the next stage of the process. And that actually gives us the key how we change our teaching. It takes a long time for new ideas to be accepted and taken on board. And many of the great scientific discoveries historically were rejected by the conservative small c status quo professional scientists. Think of Galileo, think of Kepler. Einstein was rejected by a German university who pooh-poohed and disregarded and told them his paper, his breakthrough brilliant paper, was a pile of rubbish. The scientific community is very resistant to change. The education community is 1,000 times worse. But there's good news. A book has been published on working memory related to primary education. Susan Gathercole and a colleague, who are experts in the field, have published this book, and for primary teachers it's a wonderful introduction, giving the evidence and showing how it works in the primary classroom, because the other author is a experienced primary teacher. There's a complete issue of a journal, an international journal. Every paper is about working memory, because the editor said, the time has come, we've got to get all of this out. And so there's 8 papers, and I'll give you the reference here, 8 papers all about working memory there. So it is coming. And a book publisher told me recently, and made the statement off the cuff, something like, this is the age of working memory. Its time has come, which is why I've probably been asked to speak now. You can get teaching and learning to be so much better if you just take into account there's a bit of the brain that's of limited size. It's where you do your thinking, understanding and problem solving. And if it's overloaded, learning stops.